So Dockers happen to be Docker
Mr.
basically. Ah,
Are we done with Jenkins? Are we done with Jenkins?
yes.
But you told that you were going to talk about Selenium, no? Tool and
Hmm. Yeah,
this
I
will
will
be
do that.
used.
I will do that. I'll do that. Don't worry about it.
Okay, Mr.
Yeah, Docker is far more important than Selenium. We'll come to Selenium. Don't worry. So when we talk about Docker, right? So Docker is basically a containerization thing, right? So what is the idea? You understand? First, I'll draw the image. It will be much more easier for you to understand by this. Oh, sorry, there is no paint over here. I need to take the JS paint. Okay, understand this. Let us say this is our physical machine. Okay, so I'll just write down some resources over here. Let's say I've got somewhere around 16 GB of RAM. Okay, let's say I've got around 1 TB of hard disk, and let's say I've got somewhere around um, 4 gigahertz CPU. Just for example, I'm writing. If I have to, let's say for example, launch a virtual machine on this. Oh, this thing didn't grow. Launch a virtual machine on this. What is the way of doing so? We put a ESXi layer over here, right? We put an hypervisor, right? So if you want to launch a virtual machine, you put a hypervisor, right? I wanted to make it big, but it didn't happen last time. Hang on a second. 20. Yes, now it is correct. So and to put a hypervisor if you want to virtualize this. What will the hypervisor do? It will allow you to kind of go for logically partitioning this entire resources that you have, right? So it can be anything. It can be network and every single thing. I just wrote, let's say, three things over here. It is like for all the resources you have. So it allows you to logically partition these things. And so, let's say you're running a Oracle VM virtual box, or let's say VMware, anything, VMware player. So ultimately, what it happens, your machine is running over here. It allows you to break it down logically. So let's say it says that okay, I'll make it a little bit bigger box. So let's say you want to launch another two operating systems. So let's say this is RHL, right? Red Hat Linux is running, or let's say this is, for example, Windows 98, just for example, right? So you're running two different machines on top of it. This is a concept of virtualization, right? From this, the Docker concept came. I'll tell you how. But this is the typical concept of virtualization. Now, there are two kinds of virtualizations. One is known as level 1 virtualization, level 2 virtualization. Level 1 virtualization, what happens? There is no operating system on the host machine. Okay. Directly, you are putting your hypervisor on top of your raw resources. So let's say, for example, right now I'm using a CentOS 7 machine over here. This CentOS 7 machine is running in a Oracle VM VirtualBox, which is running on top of my Windows 10 machine, right? So this one is along with, so this is more or less my configuration. 16 GB of RAM, I'm running 1 TB of hard disk, and it is 3 gigahertz of CPU. I wrote 4 over here. This is more or less my configuration. Now I am running on top of it a Windows 10, on which I have installed Oracle VirtualBox as a software. Within that, my CentOS 7 is running, which is ultimately an RHEL distribution. So this is one way, which is known as level 2. But the level 1, what I'm telling, that is a little bit, you don't see at your home. That is mostly you'll find in data centers, where let's say if I had this laptop of mine, I didn't have the Windows 10 on this. Directly, I had put a hypervisor. On top of it, I would have, I would have running a RHL machine, 98 machine, and whatever I wanted to do. So I would have saved my memory and all those things from being used up in my host operating system. If you actually want to go for virtualization where you're even giving your resources to your host operator, you don't need it, right? What is my Windows 10 doing right now? I am running the meeting from my CentOS. I'm playing on the CentOS. The Windows 10 is just sitting over there idle, correct? So if you are planning to go for virtualization, it is better to go for level one, unless you wish to use this operating system also. And level two is, so there is a host operating system on which we install a software hypervisor and virtualize, right? This is more or less the idea of level 2 virtualization. Okay, now the question is that while talking about Docker, so why am I talking about virtualization? See the architecture of Docker. Now it will be very clear to you. Why am I doing that? Let's say we have, yeah, this photograph on the left hand side is by the way for a level 1 virtualization, not for level 2. Let's say we have a 16 GB RAM, 1 terabyte of storage, and 4 gigahertz of CPU. Okay. On this, we have our this is, let's say, our hardware, right? So on top of it we have our software layer going on, that is our operating system. We have installed our operating system. So let's say here we are running, for example, Windows 10. Okay, or forget about Windows, let's talk about Linux. Let's say we are running a RHEL 8 over here. Okay, Red Hat Linux version 8. That is the software that we are running on, that is the operating system. Okay. Now we have this hardware specification. We have the operating system. What we're doing, we are putting another layer, okay, and that is what we are calling our containerization layer, orchestration layer. A lot of names are there. Let's call it a containerization layer. So you have a containerization. Oh my God, it's moving. Yeah, layer on top of it. On this containerization layer, then see what is happening. I'll explain you what it means, but just see it first. What is the effect? Okay. Now let's say I want to run a Tomcat server. I can directly put it here. I want to run, let's say, a PHP installation. I can directly put it over here. I want to run a Java. I can directly put it in a container. I want to run something in a container. So, what is the benefit of this? Let's say you want to deploy something in a container. Benefit of this. See this. In the left hand side image, that is the virtualization. If I want to install something, I have to have a guest operating system every single time I want to open up a container, not a container, virtual machine. I need to have a guest operating system everywhere. Here I have RHL 98. On top of it, I can go and I can deploy some application. I can install something. I can do whatever I want. That means if I talk about a level one virtualization, the resource allocation goes like this. Right? Let's see. Level one virtualization. Resource allocation goes like this. So our host machine has, let's talk about only RAM. Okay, this applies to everybody. Let's say host machine has 16 GB of RAM. See, in level one we do not have a host operating system, so the next RAM usage is being done by hypervisor. Let's say hypervisor uses, all these are assumptions. They are not the actual values, but practically this is what happens. Let us assume that the hypervisor uses 4 GB of RAM. Okay. Why the hypervisor need RAM? Because the hypervisor has to go for launching virtual machines and allocating the memory to each of them. So it itself has to run first, right? If it itself is not running, how will it do the job? So it itself, let's say, is using 4 GB of RAM. Okay. So you've got 12 GB of RAM still with yourself, right? Maybe let's say 11 GB of usable RAM you have with you. But let us forget about all the constraints. Let's think that 4 GB hypervisor is used. We have another 12 GB of RAM with ourselves. So now this with 12 GB of RAM, if I want to run a deployment on this RHL virtual machine I have written over here. So let's say the guest operating system, this RHL, let's say uses 2 GB of RAM. Okay. So since I have two, I'll let guest OS 1 uses 2 GB of RAM and guest OS 2 also uses 2 GB of RAM. Let's say. Okay. Two guest operating systems we have. Let's say all of them are using 2 GB of RAM. Apart from that, now you have, let's say, your the guest operating system is done. I'll just make it a little smaller. It's taking up too much of space. 18 will be fine, I think. Yeah. Now I want to run a deployment. So for the deployment, see how much RAM I have free with myself. 4 plus 2 plus 2, 8 are gone, right? So I just have another, how much? 8 GB of RAM with me. So let's say I want to run a, if you have another one, let's say another container, guest to another VM. So guest to is 3, right? So let's assume that is uses 1 GB of RAM, right? So in this way, you are throwing away a lot of RAM to run this guest operating system. On top of it, you can run your deployment. So altogether, so let's say for 3 deployments to run on the 3 guest server, we total have 4 plus 2 plus 2 8, 9 gone. So 7 GB of RAM free, right? So this is what we have for 3 deployments. Let us look at level 2 virtualization. The things becomes even more worse. Level 2 VR. What is happening? People are coming and going in the meeting. Virtualization. Now see, host machine has 16 GB of RAM. Okay. First, in a level 2 virtualization, let's say on my laptop, I am having 16 GB of RAM on this laptop, the one I'm using right now. I am running a Windows 10 installation on top of it, right? So there is a host operating system also. So right now, if I see my Windows 10 is using somewhere around 5 GB of RAM. Okay. On top of it, I have my hypervisor, which is Oracle VirtualBox. So this guy is using, let's say, for example, 3 GB of RAM, just to make sure it can manage the things, or let's say even less, 2 GB of RAM, because half of the things will be managed by your operating system itself. Here there is no operating system. This guy required 4 GB, but here we have an operating system. So this guy just needs to do the virtualization, not the operating system job. Here this guy was doing everything, hypervisor. But anyway, level 2 hypervisor uses less RAM, 2 GB of RAM. Now I have, let's say, guest OS 1, 2, and 3, right? So they are using, let's say, now here you need to give a let them a, let they let's say you thought of giving a little bit more RAM, so 3 GB of RAM, right? The better, the more the RAM you give, the more the performance you get. Simple, right? Uses, let's say, 2 GB of RAM, for example, right? Your this guy uses, so you can understand ultimately. I'm not writing, so you're wasting a lot of resources over there. But now look at your this Docker, okay? So this can be either Tomcat installation. That means what? The deployment will happen here itself, right? You have the Tomcat, means you are going to put the application there itself. This container is going to be a completely deployment container. This container is going to be a completely, it's a PHP based deployment container, right? So this is what is happening. So now see, in a containerization, host machine has 16 GB of RAM. Okay. Host OS, okay. Host OS uses, let's say, now we are running a Linux installation over here. Linux anyway uses less amount of RAM. Let's say it uses 4 GB of RAM. 4 GB is fine. Our containerization engine, that is this guy over here. uses, let's say, well, now the benefit over here is that containerization engine, honestly speaking, does not use any RAM practically. I mean, it is like extremely less, some 500 MB or something like that. Whatever it gets, it will be transferring to the containers. It uses a minimal amount of RAM. And how it works, see, containerization engine uses exactly the RAM amount it needs to supply to the containers. Okay. So if you are running, let's say, 4 containers, and the configuration is like that each of these containers require 4 GB, let's say 2 GB of RAM. It will take 8 GB, a little bit, let's say 8.5 GB, just to make sure that it itself can run. Okay. So it is more or less practically exactly how much you need over here. It is not eating up anything else. So the rest of the RAM you have free with your operating system. They can use it if they want, simply. So it uses whatever it requires to supply to the containers. Now, each of the containers are running using the using the OS power from the host operating system. Each of the container is running using the operating system power, so it requires the part of the operating system in order to run. Okay, it will be requiring the uh, without an operating system, nothing can run, no application can run. So the operating system power that it needs, it is directly sucking it from the host operating system, right? So therefore, it does not need guest operating system. Here there is no operating system. Directly on top of containerization, your Tomcat deployment is running. So on this containerization layer, you can directly put the Tomcat installation. You can directly go for a PHP installation, Java installation, whatever you want. You do not need to have a guest operating system because the operating system power that it requires, it is taking directly from the host operating system. Okay. And another benefit, so this is just from the architectural point of view. Another benefit that comes into picture, let's say in a VM kind of an architecture, you want to say that, okay, I want my RHL machine to have a little bit more RAM. You have to stop it, you have to add more RAM virtually, and then you have to start it once again. In containerization, resource management is dynamic and on the go. On the go means what? When it is running, automatically it will be, if it sees the Tomcat installation requires, Tomcat container requires a lot of resources, it will immediately pass on more resources to that. It will automatically take it from here, from let's say the host machine, it will pass on to that particular one, right? So it will always make sure, and also there is a resource based load balancing that goes on. Means what? If Tomcat, and let's say PHP is running with 5 GB and Tomcat is running with 3 GB, now Tomcat requires 5 GB, it will immediately transfer 2 GB from PHP to here if PHP does not require that much. Getting the point? So whenever who is requiring the RAM, or let's say the other resource, it will kind of keep on transferring the things from here to there. That is the thing that it will do. So this is a basic difference that I tried to bring out between our typical virtualization and typical containerization architecture. And also through this, I wanted to tell you that what exactly containerization is. So now I think you have more or less an idea, right? Containerization is when you're putting a containerization platform on top of your host machine, and then you are launching small containers over there where each of the containers can contain one whole deployment, right? So your deployment engineer, now when you're doing DevOps, you're automating, but typically speaking, your deployment engineer, he does not need to know how to deploy, let's say, Python, how to deploy Java, how to deploy .NET application, and all those things. He doesn't how to deploy PHP application. You might keep on adding more and more modules to your application. He does not need to know everything about everything. You whatever module you are putting, you just supply it to your home, to your deployment engineer. He just deploys the container. Done. That is one benefit. Another benefit that comes into picture is that, let's say, this Docker containers and all those things we can build completely, from something known as a Docker file. So there's a Docker file that you can write. Within that, you can write down all the configuration, and you can directly build the containers. Oh, I'm very extremely sleepy today. So what happens when you do that? So let's say you have your developers. They are writing their code in a particular environment. They are using a particular version of Tomcat, particular version of Java, particular version of Maven, this and that, etc., etc. So you just get that configuration written in the Docker file, right? So when you are getting the code from GitHub and ultimately putting it over there, push the Docker file also. So what will happen? You can run a build of the Docker file. So you'll have exactly those things, right? If the developer has used Tomcat version 8, Java version 10, so you can just get it written in there and you can just deploy that. So when you're running, what it does, it automatically creates a Tomcat version 8 deployment on Java version 10. So when the deployment is being done, right? So first it will install Java 10. On top of that, it will install Tomcat version 8, whatever is required for that. And on top of it, it will deploy the application, right? That is how it does it. So ultimately, your thing is done, your job is done, right? So it happens very, very fluidly. You don't have any option like there they were using different version. Here we're using different versions. So what will happen if the versions do not match? The things will not work out. That problem doesn't come in because you do not have the version kind of a problem anymore. The versions, whatever you need, just write down in the description and send it. So that while running, so before deploying your application, first it will check whether or not you have the actual environment prepared. If it is not, it will match with the description file, right? In fact, it doesn't do all those things. Just simply when it is trying to do the deployment, it will first delete all the existing environment. It is putting from the Docker file all the all the exact installations of the applications. On top of it, it is going and doing the deployment. So you help yourself a lot in terms of uh, getting rid of the environmental differences and therefore whatever issues might arise because of that. So you are saving yourself out of that. Containers are small boxes that you're kind of putting on a containerization platform, and each of these box can run applications, one application, multiple applications, however way you want, right? Typically we go for different containers for different applications. We do not install multiple applications in one container, but if you want, you can do so, right? You have the complete authority to do so, right? I'll show you both the ways by putting multiple applications, single application. Okay, who is multiple times going out and coming in? I'm hearing the sound, repetitively. Anyway, fine, great. So, more or less, we are understanding, right? What is going on over here? Everybody? Yes. Can I get a response, please? Malikarjun, clear? Huh? When we'll see this practically, it'll be much more clearer. Yes, others?
Yes, we shall.
Okay. Bhagavan, Moina, Karthik, Junaid, Krishna, Mithun.
Yeah, we
Yes.
shall.
All right. So now, let us go and let us try to kind of try to do these things by ourselves. Okay. So when we'll be learning this, I mean, let's say today basically. So after this, when we will be trying to integrate, that is tomorrow, let's say, with Jenkins once again, right? So that point of time, you'll be seeing that we are doing the continuous integration, continuous deployment. That time it will become CI/CD. So far you have done CI part, you have not done CD part, right? You have done half of it. So when you do this, then it will become CI/CD. So what will happen? You will be pulling something from GitHub. We'll be building using Maven, testing using Selenium, right? Then ultimately it will be generating us the WAR file or the jar file, the packaged in the POM, whatever the packaging is written, jar or WAR. Let's say WAR file it will be giving us. That WAR file will be copied to this machine where Dockers are running. That will automatically from the Docker file build the environment. On top of it, it will do the deployment, right? That is how this thing will work out. So we shall absolutely see this thing to happen in front of us. Okay. All right, let us go and let us do that. there are a huge set of commands. These commands will be pretty much clear once you see all of them, but the thing is, I mean, when you first time see, you'll be feeling like so many commands, but actually these commands are not very difficult. So once again, the same suggestion: first understand the thing. The commands you can find online everywhere. I will also, like copy paste the commands in your whatever document you have in your group. So the commands you will get when I'll be doing the things, rather than focusing on the commands too much, try to focus on the these things, right? The actual idea, what is going on. Let me log in. Right? The Docker installation can be done directly through your YAML package. You can go for like sudo yum install Docker. Right. So this is one thing. Nice. Now, when we have the Docker installation done, so you can just check it by writing Docker version. So you'll find out that the version is being shown. So you can see 18.09.9 Community Edition CE. Okay, build number, whatever things are coming. So now what I want to do over here is that once Docker installation is done, I want to set up. So see, let me show you something. Um, let me take you here. There is something known as Docker Hub. Okay, just like you have GitHub. So we have to run a Docker pull command, just like we do a git pull to pull from GitHub. So what we do, we install git and we do a git pull, right? So we'll have installed Docker. Now we can do a Docker pull. So in this Docker Hub, we have got a lot of images. These images will be ultimately pulled and ultimately used. Okay, that is the idea of the images. So we'll be pulling an image, and when we run that image, that is called a container. The running state of an image is known as a container. If you stop it, the container will be deleted, or the container will be just stopped, let's say, basically. So running an image is known as a container. So you can find like thousands of images over there. Let's say, for example, if I want to pull, I mean, you can find operating systems also. If you want to see Ubuntu, oh, it's a wrong spelling. If you want to find Ubuntu operating system, you will find that one also. There is everything that you can have normally, whatever software, an operating system software, an application software, whatever kind of things. MySQL database you will find over here. You want to run a container of MySQL database. MariaDB is coming over here, right? And Percona is there. So if whatever you want to run, you can find it. Let's say we want to run a HTTPD server. Okay, that is our Apache web server, right? This one is our this logo, right? Apache web server. So Apache web server is known as the HTTPD server. So I want to install this. I can do this, and the command is very very cool. So whatever name you're seeing over here, you try Docker pull and that name. See this. If you open it, it will tell you what you have to run. docker pull httpd, right? This is the command you need to run over there, right? So if I pull httpd, then our web server will be pulled. Now you can see directly we are running httpd, but do not have any like Ubuntu or something on top, right? Directly in a container we are running it. So let's go ahead and let's do it, right? Let's pull this one httpd. So before doing that, I'll show you that you want to see the docker images. You can go for sudo docker images. Okay, the docker is not running, so let me start the service. Sudo service docker start, right? Now it is started. Now see, sudo docker images. You'll be able to see what images there. Right now it is empty, there is no image, just the headings are coming. And you can see sudo docker container ls. That will show you whatever the list of containers you have, which is also empty. Okay, this container ls can also be seen like this: sudo docker ps. Ps means processes. If you write ps, you will, that is the same command as container ls. In older days it was ps, and nowadays it is called container ls. They have not removed the old command. Okay, initially it was like images and ps. I have always used images and ps, but nowadays we have got the container ls command also. Okay. Similarly, when you want to delete an image, delete a container, there are new comments and old comments. I'll come to that. Okay. But one thing that I want to fix over here is that every single time I have to write sudo sudo sudo. Either I can log in into root, or I have to write sudo 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 every single time. But this is bad, right? I mean, why should I write sudo every single time? Let me make one thing. Let me add my EC2 user to the group of Docker so that I can use it without sudo. Right? I'm going to add EC2 user to the Docker group. So sudo user mod, that is called -a-g, append one user to a group. A means append, G means group. I can write like this also, ag. Same thing, -a-g can be written like ag, right? So I'm appending one user to the group. Which group? Docker group. Which user? EC2 user. Now that I've done this thing, okay, it should work out. But for that I have to restart the session. Let me exit and let me log in into once again. Right now, if I run docker images, sorry, images, you'll find out when it is working. It is showing me the output, right? So I did not show you over here by running docker images. Had I shown, you would have seen that there is a no authentication error will come. You are not authorized to run this command, like that will come up. Now that I have added this one, now it is working without sudo also. So this was the main purpose of doing it, right? So now we are kind of good to go. Every single time we do not need to run sudo 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 like that. Simply you can run it. Okay, we have to pull the httpd image, let's say. So I can go for like docker pull httpd. It is downloading. Okay, so you downloaded the latest image of httpd. If you wanted a particular version, you could have done that like this. See, all these are versions: 2.4, 0.41, 2.42 latest, right? 2.4.41 alpine, right? So a lot of versions are there. So if I wanted a particular version, let's say I wanted version 2.4 for example, then so right now check the docker images. You'll find out that this one is there, httpd latest, right? If I wanted that one, then I could have gone like colon 2.4. This is how you write it. Okay, colon the version, then it will pull httpd, right? Downloaded new image. So now we'll go for it. So docker images. Array, it got stuck. It got stuck. So you can see now we have got 2.4 also, latest also, right? Both the images are coming over here. So both the images are having the same image ID. What that means? That means the latest version actually downloaded 2.4 only. When we say this dot download, so latest version, the latest will always download the latest, you know LTS, right? Long term support release. It will always download the LTS version. So 2.4 itself is the LTS version. So when I wrote 2.4, it downloaded the same version only, right? So we got the same image ID, correct? Actually, if I want to remove one image, Docker RMI. RMI was the older command to delete an image, remove image, okay? RMI. So let's say I want to remove which one? HTTPD 2.4. This one. It is deleted. See, it says untagged. It does not say deleted. Why? Because if it deletes this one will also get deleted because both of them are ultimately the same ones, right? So now if you see Docker images, you will see only this one is being shown. They both of them are the same ones, right? I'll show you some another example where you will see there are two versions being downloaded. Like let's say for example, if I do a Docker pull, let's say Ubuntu server, okay? Docker pull Ubuntu. Now typically if I write Docker pull Ubuntu, it is done downloading Ubuntu version, something, whatever. So if you see now Docker images, right, you'll find out there is Ubuntu latest version installed, okay? There is a particular image. If I download, let's say Docker pull Ubuntu, let's say 16.04, which came out like 2 years ago, right? Then see, it is again downloading. Can you see last time when I used HTTPD, it did not download for the 2.4. It just got it from there. So now if you see Docker images, you'll find out. See, Ubuntu is running in two versions. One is 16.04 image also I have downloaded. Latest version also I have downloaded. Latest means I think 19.04, mostly 19 or 18.04, anything like that. So this latest will always download the LTS version. And if you mention the same version over here, then of course the thing that happened with the HTTP, the same thing happened. That we downloaded the same image twice. Otherwise, you know what to do. And now, if I want to delete, let's say for example, the Ubuntu version latest. So once again, Docker RMI will work. Right? Or let's say RMI you already saw. The another way, the newer way is to Docker image RM. Image, sorry, not dash. Image RM. Image RM is the newer way. Okay. The older option was RMI. RMI and image RM does the same thing, but nowadays we write image RM. But anyway, you will find me writing RMI a lot of times because I kind of am habituated with that. So let's say I want to delete the Ubuntu 16.04, for example. So I can just do that. So this time you can see it didn't only untag, it deleted also, right? But when we tried to do for the HTTPD, it did not delete, it just untagged and left it because it was the same image. But here it actually deleted the image. So now you go for Docker images, you'll find out there is nothing, only these two. That one is gone. Okay. Guys, are you all clear so far? Yes? Hello?
Yeah, hello. Yeah,
Okay. Pakka na?
yes.
Karthik, what about you? Understanding?
Yes, Vishal.
Okay, great. Sure. Whoever is in the meeting, in case I'm not following the participant list. If you're in the meeting, just let me know whenever you are stuck at any point. Okay. I mean, do not think like this is the first time you're doing this. You might be stuck at multiple points. Just let me know that. Like, otherwise, I'll not understand. Okay, so we're finding the Docker images like that. Now, how do we run an image? I told you that running format of an image, running version of an image is known as a container, right? When you run it and when you run an image, that becomes a container. So let us run an image, right? Let's, for example, run the HTTP latest version. So Docker run. Now there is a thing. You have to say -it. So if you want to, you have to write down the image name and the tag name. So for that, you need to write down -it. Okay. Or you can write down -i-t if you want, ultimately. Then you have to mention your this name. This is the format. This is the command Docker run. If I do so now, see what will happen. See, it ran, but it just stopped like this. I'm stuck over here. I cannot go anywhere else, right? So if I open up another terminal, see this. If I open up another terminal, let's say, and try to log into the same machine from another terminal, okay? I'll keep it a little small. Same machine, I'm logging from another terminal. See this. What are you doing? Okay. See, I am trying to log into this machine. The internet connection is unstable. It is flying anyway. When I'm logging into this machine, from here, if I run docker container ls, okay, you can see there is a container running, right? Called HTTP latest, isn't it? Container, this is a container ID. Status is like up 58 seconds ago. This is the status. It is running on port number 80. Of course, web servers will run on port number 80. Okay, it is given a wonderful name. The name is relaxed leaky. Automatically it will put a name. Okay, it will put some funny names. HTTPD foreground 59 seconds ago. It is showing. Now, why did I open it in different terminal? Because if I exit it out of here, and then if you run, or let's say, no, if you run once again on Docker container, you'll see there is nothing. So as soon as I exit over there, the container is dying, right? Because it is no longer running. That is what I wanted to tell. That when I just ran it, Docker run, it started running. But now I am stuck with the terminal. If I close the terminal also, it will get stopped. Right? But that should not be the case, right? If you want to see the older containers, you can put a dash A. Dash A means all. So it will be showing you the see it says that exited 35 seconds ago. This container was deleted 35 seconds ago, right? Container got deleted. If I want to remove the container, completely delete the container, then I have to go for docker container rm and this name, whatever the name of the container is, right? So it will be deleted. So now you can see if I do docker container lsa, it will not be shown, right? It is gone. Right? So now this is a real problem that I cannot really close my terminal. If I close the terminal, the thing is gone. So how can I work around on this? Let me close this one. I don't need it anymore. So the thing is, when you are running the docker run, put a dash d and then push your dash id and write your image name and all those things. I'll tell you what it means. D basically means daemon. Daemon thread means what? The background thread, the service thread on which the services run, right? So when I do D, it will be running on the daemon threads. This time it will be running in the background. See, it shows me a hexadecimal ID, but it comes out. So now if I run docker ps, which is equivalent to docker container ls, the same thing. If I run docker ps, now this is running without any hesitation, right? And it does not stop me also using the terminal. If I close the terminal, it will not get stuck. That happened because I ran with the dash D flag. So now onwards, whenever we shall be running something, we'll be running with the dash D flag, only because of this reason. Okay. If I want to stop this, Docker stop. Right, you can stop. Docker stop. This particular thing, dazzling gauze. This name you have to kind of copy paste. Okay. So now if I see docker ps, you will see it is gone. But once again, if you go for docker ps a, that is docker container lsa, the same thing, you'll find out it is coming up and it will say that it is exited, right? So now we can control it much more efficiently. We do not need to enter the console and enter the shell and stop over there. No, we can run it on the background, right? And you want to delete this, so you can go for like docker rm remove, right? See, this rm was used earlier. Now it is container rm. Container RM and image RM. But earlier it was like simply RM is container and RMI means remove image. So it was a little bit difficult earlier. I mean, you have to remember. But now it is very easy. Docker image RM means you are removing an image, which is pretty straightforward, right? Docker container RM means you are removing a container. But only RM will also work only because that was the backend, older support, right? What is that outside? Okay, okay. Fine. So it's fine. So far, so good. Now the question is that, so if I'm running my container, how can I give it a name that is a little bit, like a readable name? This dazzling gauze and something name it is automatically putting. How do I know what name it will put? If I have to control from Jenkins, I have to delete a container before I can put a new container, right? So now, how will I delete the container if I do not know the name? I cannot control it, right? So I should be able to control it by the name, because you can see I'm controlling by the name only. The ID can be anything. Every time a new ID will come, but at least the name we can control. How? Like this. See this dash name. Okay, and you can write a name dash name. So let me call this thing my HTTPD. Okay, so this name I'm giving to it. Also, now when I'm running a container of a web server, I should be able to reach the web server from the outside, right? Otherwise, there is no point. You do a deployment of a Tomcat, and the Tomcat is only reachable within the local host. It is not reachable from the outside. The deployment does not make sense. So now, if you have noticed, you saw right that it actually opened up on port number 80. It was showing 80 TCP. Now this container is opening up port number 80. So I need to open up some port on my host machine also so that I can connect that port with this port. So that is called a port mapping. It can be done with the -P. I want to do a host port 80 on container port 80. If I write this, then on my host, if I hit port 80, that will take me to the container port 80. I can change it also. I can say that when I hit on host port number 8080, that should take me the port number 80 of the container. So in the containerization platform on port 80, who is running? Our HTTPD server, right? When we will be running this. I mean, once this command is finished, I press enter, HTTPD server will start running on port number 80. So I can map like this. I can say that port number 8080 on the host machine should be mapped to the port number 80 of the container, right? Or I can do like 80 on 80. Typically, people keep it same. They do the same. So if the container is exposing on port 80, you connect on port 80. One thing you can do, let's say you are doing a Tomcat deployment, and the Tomcat deployment runs on port 8080, right? So the container will open up on port number 8080. I can say that map my port 80 of my browser, sorry, not browser, sorry, port 80 of the host machine to port 8080 of the container. So what will happen? Now in the browser, if you go and write the IP address, you press enter on port 80, it will automatically come to port 8080. So you do not need to write down the colon 8080 on the browser anymore. That is one benefit you can do. I'll show you that by doing it. Anyway, as of now, let me do a 80 to 80 mapping, let's say. Okay, and another thing I want to do is uh, the image. So the image is going to be HTTPD latest. Now see this. If I show you the Docker PS right now, you'll see it is running with the name my HTTPD, right? It runs with the name my HTTPD, and there is a port mapping from the internet on port number 80, right? There is a port mapping from the internet. 0000 means the internet, right? From the internet port 80, it will come to the port 80 of the container on TCP protocol. TCP protocol means HTTP will work out, right? Let us try to see this if we can reach the HTTPD server. So I'll go here. I'll open up first port number 80. Okay. So I'll open up two ports over here. Okay. I'll open up port 80 also and port, let's say 81 also. Another one, let's say port number 81. So now see why I opened up 81, I'll tell you. As of now, let me save it. Let me take the IP address. Let me copy it, go to the incognito window, paste it, hit it. Right? This is the typical message that comes when you have a HTTPD container. It says it works. It is working, right? So now, so we mapped from, so our HTTP server container will always run on port number 80 only, right? But we mapped port number 80 over here to port number 80 over there. Let us say I want to map. Okay, I'll stop this. Okay, Docker. No, I'll do a force removal. If I remove by force, automatically stop and get removed. Okay. It's gone. I want to create it once again. But this time I want to map port number 81 with port number 80. So host port 81 going to container port 80. If I do so, now you will see this will not give you any output. This will just keep on rotating. Because see the Docker PS. Port 81 is mapped to port 80, right? So 81, whenever someone hits on the browser on the host machine, that is the host machine IP, they will be forwarded to port 80 of the container. So see, it does not give any response on port number 80. But if I hit on port number 81, then I'll be taken to the container port 80, right? So the container is still running on port 80 only. But from here, so this is what I was telling. If I have my container running on 8080 Tomcat instance, and here I make it 80 to 8080, so I can just hit the IP address, my Tomcat will open. I do not need to go for putting 8080, right? So if there is a Java-based application, like let's say IRCTC, when you're writing IRCTC, do you need to write on irctc.com colon 8080? No, right? You just irctc.com, press enter. How does it work? Because this is a load, port forwarding has been enabled over there. This is called port forwarding, right? Forwarding from one port traffic to another port traffic, right? Guys, are you all clear on this part? Yes? Yes, no, anything?
Hello.
Yes. Tell me. Hello? Can you hear me? Are
Yeah, Vishal.
I am audible, right?
It's audible.
Yeah, Vishal.
Okay. I'm not getting any response from your end. Fine. Are you having very difficulty
Vishal,
to
where did
understand
you?
this thing?
Hello.
It is clear, right? I mean, at
Hello.
least somewhat. Yeah.
Yeah, yeah, somewhat. Yeah, it's clear.
Fine.
Hello.
Hello.
Yes, yes. Please, at least give me some response so that I can understand that you are actually understanding.
Yeah, sure.
Hello.
Yeah, yeah, Bhuvan.
Vishal.
Tell me, I'm listening to you. Anything?
Actually, hello.
Ha.
We are receiving this it works message, right?
Yes.
So where we have written this it works message actually.
We have installed HTTP, na? HTTP Docker container by default comes with this message. It works.
Okay. By default it comes with it works.
Exactly. Yes.
Okay. Yeah. Okay.
Right. If you deploy some application, some website on top of it, then it'll be replaced with that one. But the default message is it works.
Okay. Because earlier when we hit the Apache or something, no, so we used to.
Index.html, we used to change it.
Yeah. Okay.
Correct. In that way also you can do. You want to see? Let me show you. Hang on a second. Okay, I'll kill this one. Okay, I'll kill this. That Apache that we used to do, that one if you want to do that also you can do, and that you can do only because I have the Ubuntu image also with myself. So if I run the Ubuntu image, first of all let me run on the foreground just to show you that it is actually the Ubuntu image. See this. But this will now become like a virtualization because I'll be having the Ubuntu on top of it. I'll be installing Apache 2, which is not exactly what the containers do. But anyway, just to show you, I'll do this. See, let's say I'm doing Docker run IT and running the Ubuntu, okay? Ubuntu latest. See this. You are all logging in directly as a root. If I do an ls, see these are all Ubuntu things, right? Home. If I go to home, ls, right? So there, as of now, there is nothing. If you create a user, that will come over here. This is actually Ubuntu. Okay. So now, if you see, let's say I can run apt update. This will work. See, security.ubuntu.com. It is actually Ubuntu. So on top of it, I can install your apt install Apache 2, right? So then it will happen whatever what you are telling, right? Let's say I'm installing Apache 2 over here. I've installed Apache 2. Now is the service running? So, service Apache 2 status. It is not running. Let us start it. Okay. So now it is working, right? So this particular thing is running. Is it running? Error setting the limit. Starting. Okay. I think it is running now. Yeah, Apache 2 is running, right? So now if you go, you will find that orange color page that comes up typically, right? So just check it out. I did not do any port mapping. Unfortunately, you cannot open up. I need to do a port mapping for this, right? But the problem is since I ran it on the foreground, if I exit, it will be completely deleted. So there is no option. So anyway, let me exit. I'll do it once again. So I ran it on the foreground, right? So, and I did not do any port mapping. It was open up on port number 80, but I did not do any port mapping, right? So I will not be able to come and connect it from the outside. So when I'm running this, I have to do a port mapping. Okay. Or let's say, let us run it in, behind, not exactly on the front. I'm writing a name called, let's say, my Ubuntu, and I'm giving a port mapping of, let's say, port 80 to 80. Okay. 80 to 80. Fine. So now it will run, in the backend. So if I want to log in into this machine, then I can, get into the shell of this machine. I have to go like docker exec means execute, exec bin bash, I think, on Ubuntu latest, something like that. Oh no, I need to, okay, I forgot the docker exec command. Hang on a second, let me find out the
This port mapping is necessary for all.
If you don't do port mapping, how will it connect? From outside port, you are not giving any connectivity. No, you are just saying that it will automatically expose itself in whatever port you are saying. Whatever port it needs to. If it is a MySQL, 3306. But if you do not connect it with the host port, from the host you will not be able to enter. Within the host you can reach it, but from outside you cannot come. That is why the port mapping is done. Okay, let me log into this machine, that this container that is running. So docker exec. If I'm not wrong, I have to go for T my Ubuntu. Let us see if it works. No, it's not working. I need to see the docker exec help. So using docker exec, what you can do, you can log in into a running container. Okay, docker exec. The TT will not work out. Interactive. Okay. Okay, fine. Docker exec. I have to see the command. Hang on a second. Docker exec command. Docker exec command. Docker exec IT bin bash doesn't work. Okay. Let me see what they're telling. I want an example. Ubuntu bash. Okay. Okay. I don't want to run it on background. I'll run it on foreground. The command I want to run on foreground. So docker exec IT. I think this is how you do it. Okay. Let's try to do it. So docker exec IT my Ubuntu bin bash. Oh, here it comes, right? So you have your, now we can go for apt update, right? And we can go for the installation of your apt, that one. Apt install Apache 2. It got stuck. It's getting stuck multiple times. I wrote Apache 1, Apache 2. So now it is getting installed. You can see this is running properly. So we can go for, let's say, docker, sorry, not docker. We can actually see this right now. So the port mapping has been done, so you can see this. Come here and hit on port number 80. Now this one does not exist anymore, right? This I've deleted already. Hit on port 80, you will see the, wait. Maybe I need to come out of the shell or something. Oh, so the Apache 2 is not running, I think. No? Service Apache 2 status. It is not running. Let me start it. Then only it will work out. So now if I go out, if I refresh the page, here this typical page is coming up because it is now installed on Ubuntu. It is running in a container but installed on Ubuntu. So that is why the Ubuntu default page is coming. If you install the HTTP Docker page, that will show it works. But when you are installing your Ubuntu on Ubuntu, it is coming like this. And to install a, you can just go and what was that? www.html, right? So if I go to that particular folder, sorry. we do an else, there is the index.html, delete this index.html. So rm index.html and create a new one. So let's say go and write down something. Now see this. Bhagavan, clear?
Yes, okay.
Okay.
Got it.
Yes. Others, did you understand? Was it clear to you? Mallikarjun, clear? Okay, nobody seemed to be responding. That's fine. Let's go ahead. And we can exit out of this container. I mean this shell also. Still the machine will be running. I mean there is no problem because it is running on the background, right? It will keep on running. So the only way to kill is this that Docker. Actually, remember this thing. If you want to remove an image, let's say Ubuntu latest, you cannot do it as of now because this image is currently now being used in a container, right? In a container, this is being used, so you cannot remove this. Fine. This is one thing. Remember. And let's say I want to completely delete the container. Once again, Docker stop. Typically in a production scenario, you should stop and then remove. You should not directly remove force. Here I was doing it for faster. Okay, Docker stop. What is the name? My Ubuntu. Something Docker remove my Ubuntu. Is gone, right? So now if I try to do Docker RMI Ubuntu latest, it should work out. No, it is still being used somewhere. Container something is using. Achha, Docker. Hang on a second. PS all. Oh, I have this guy running over there. Competent Thompson. That one is like when in the foreground I entered, right? It is that one. Now if I try to remove the image, I should be able to do it. So it is like Ubuntu latest, and it is gone. See. So check the Docker images. You just have only one. That is the HTTPD latest version, right? Anybody any doubts so far on anything, whatever we did? Yes, guys. Any doubt? Please tell me.
No, Vishal.
No.
So now that you have understood the basic operations on it, now we need to understand how we can build a Docker file and we can work through that. Okay. So it's extremely easy actually. So Docker file has got a particular syntax. We have to write within that, and that is also very easy. Once you start writing, you will understand. So let's create a Docker file over here. See. Now the name that Docker file by default should have is Docker, just Docker file, capital D, Docker file. That's it. F is small. But if you have a different name, then you have to specify during running the build command that okay, this is the name I am looking for. If you do not want to do that, then just call it Docker file. That's it. Capital D. Let's say I want to do exactly the same thing that I had done so far, right? So I downloaded the Ubuntu image, that Ubuntu thing that I just now did to show Bhagavan, right? What I did, I downloaded the Ubuntu image, I installed the web server within that, right? And also I ran the web server. So this is the command that ultimately, this is the thing that I ultimately did, right? So if I want to do that through a Docker file, so I don't need to run a Ubuntu, enter and do it every time. Because understand, if I just have the Ubuntu latest with myself, every time I want to deploy let's say an Apache on the Ubuntu container, I have to every time do a Docker exec, enter to the Ubuntu container, go and install it, start the service, come out, right? So it cannot be like directly run the image and it starts running. That will never happen, isn't it? So what we have to do, we have to take the Ubuntu image. So from the Ubuntu image, we want to do the installation of Apache and again, like keep that installation as an image. And from there, I want to run the container. So every time I run the container, it will run. So the thing that will happen is going to happen like this. See. this image, I mean, if you need, you can take a screenshot. Okay, I'm deleting this. Fine. Okay. Now, see, what we're trying to do over here is, so let's say I download the Ubuntu image. First thing is downloading the Ubuntu image. Number two, install updates, install Apache 2 on top of it, right? And this entire thing that has happened, stored this manipulated, this is manipulated, right? It is no longer the fresh Ubuntu image. It is like Apache installation. Stored this manipulated state as a new image. Okay. This is what we can do using Dockerfile. So next time onwards, whenever I will be, let's say for example, now we can run this new image to get Apache 2 pre-installed on Ubuntu, kind of a flavor. Clear? So if we have the downloaded Ubuntu image, we are installing the updates, we are installing Apache 2, and we are storing whatever the current state is as a new image. Just like you start from, let's say, your Ubuntu server, you install something and you take an AMI, right? When we do AWS, right? I'm just trying to draw a reference. When you do AWS, what do? You take an AMI of that, so that later you can just launch from there. Similarly, here also we are downloading the image, we are installing the updates, we are installing Apache 2, exactly what we did just now by doing exec. The same thing, and we are storing so far what we have done as a new image, right? So that whenever we run this image, it will be opening up as the container itself will be having the Apache 2 pre-installed, right? That is the idea. Let us go ahead and let us do that. Let's see how we can do it. So we are starting from the Ubuntu image. You have to write down from Ubuntu. From means where you are starting. Always remember, you have to start from somewhere and go till somewhere. Uh, just like I gave you the example of AMI, can you start from nothing? No. You have to start from somewhere, then go till somewhere. So you're starting, let's say, from Ubuntu. I want to run apt update, right? Then I want to run on top of it apt install Apache 2 -y, because if I do not give the -y, it will not be able to do it. There is no manual intervention. Remember, it is automatically happening, right? Run apt install Apache 2y. So if I do just this much and I save it and I just build this one, so what it will download the Ubuntu image, it will open that up, it will update, it will install Apache 2, it will again package it in an image and store it. But I don't want to stop over there. I need that whenever I'm running the container, the Apache 2 should start automatically, because you remember, right? It is stopping, right? It is not started. So I need to run a command for that one also. So, no. Run is used what you want to do before you package the image once again. But this command I want to run when I'm running the image, when I'm making the container, right? If I do run, it will do that, but then it will package it. But when you're packaging and you're storing it, later when you're running, it does not automatically start, right? So the run I cannot write over here. I have to write CMD, right? So there are some 4 or 5 different commands. From is one. From is like where you are starting from. So the architecture, the option goes like this: from, then run whatever you want to run, then after that expose, because this time it will not expose port number 80. You have to write expose 80, right? So from is one set of command, run is one set of command, expose is one set of command, CMD is one set of command. So run is run while downloading the image and then manipulating that, and CMD will be run when the manipulated image that you have got, that you are trying to run as a container. That point of time, the CMD will be called. Okay. So in the CMD, I want to say, let's say Apache 2 CTL D foreground. That is how you start it, basically. This is the way you need to start. I think Apache CTL, not Apache 2 CTL. This is the way we start, container, sorry, Apache server from outside. So from Ubuntu server, once I'm repeating, take it from Ubuntu server, run the update, run the installation of Apache 2. Once these things are done, then please expose port number 80, and after expose port number 80, it will store it as an image. So it will create a new image. On that image, when I'm trying to run a container from that image, I want to run this command, that is apache ctl d foreground, which simply means service apache 2 start. The service apache 2 start we cannot write from here, we have to write apache 2 ctl d foreground. Okay, that's what it is. In case you are not sure where you are writing this particular thing, I will show you what it is. Let me save this. Okay. Okay. If you want to see this particular one, right? So just run the docker run on the foreground, run the httpd, right, and see. Okay. httpd d foreground. Can you see? This is how the command is written, right? So since I'm running Apache, I'm writing Apache CTL. It is called Apache CTL. Apache CTL d foreground, right? This is the command I used over there. Same thing. Anyway, let's exit it. Right, so we create a Docker file, right? So if I get the Docker file, you will see this is what it is. Written from Ubuntu, run the apt update, run the installation, expose port number 80. Just before your CMD command start, it will be packaging it in an image, and then it will, whenever you write like docker run something, it will execute the CMD command. Okay, see this. We need to run a command docker build. Okay, docker build is to build the Docker file. Now it is in the current directory, so you'll be putting dot docker build dot. Okay, see what is happening. It is downloading the Ubuntu first. It is running apt update, right? You can see, right? The update is going. Then it is, I think it is installing the Apache 2. So it is installing the Apache 2 right now. Unattended, right? So it then exposed the port number 80, then ultimately the CMD command came into picture. So everything is finished, successfully built. See the Docker images. How many images we have? 3, right? One is HTTP, one is Ubuntu downloaded. We did not write any name for our new image, so our new image doesn't have any name, but at least it is there. Fine. This is the new image. Getting the point? This is just 64 MB, but this is 188 MB installation of Apache 2. Correct? If I have to run this now, I did not have any name, so I cannot use IT. So I can go like docker run -d, and I think if I put IT, I can put the ID also. Oh, that's a wrong name. It is up and running. See this. I did not do any port mapping also. I did it wrong. While doing Docker run, I should have done a port mapping. If you do a Docker container ls or Docker ps, whatever, I'm getting stuck. Look at the output once it comes. It is running right on port number 80. Correct? Have you got the view? Are you seeing it? It is running on port number 80. We forgot to do any port mapping, so let us do a port mapping. Okay. I'll kill this. So Docker rmf. Also, I want to do another thing, that when I did the Docker build, I did not give any name and tag, right? Let me give it a name and tag. So let me first delete this image. So Docker RMI. I'm deleting the image. So let me again do a Docker build. Okay. But this time I have to give it a name. Okay. The name I have to give, or no, it is not called name. Hang on a second. I think it is called -t or something like that. Let me see the help. Or what is the name? How is it given? Tag list. Name and option tag -t. Using -t, you have to mention this name tag format. Okay. So let's say I'm doing -t. I'm going to call this thing modified Ubuntu version 1.0. Okay, this is the name I'm giving to it. And then I'm doing the build. And also, yeah, fine. Then I'm doing the build. So once again, it will do the same thing, right? It will again do all those things. Let it do it. You can see successfully tagged mod Ubuntu. It is telling, right? So now, if we want to see the Docker PS, see this. Oh, it is not there. Sorry, we have to run it. Now, if we go for Docker run, and I want to now this time do a port mapping. Okay, give it a name. Let's say my Ubuntu, right? And also do a port mapping like 80 upon 80, right? And then run the one that is mod Ubuntu, mod underscore Ubuntu, because that is the name and tag I gave 1.0. Now see this. This is going to, by the way, just to show you the Docker images, see this. If I go for Docker images, you can see it is coming with mod Ubuntu 1.0 this time, right? Fine. Yeah. Right. So, and it is running also. So if I go ahead and if I try to kind of hit that particular one, this particular IP address to here, running. Fine. So it is built from the Docker file. The Docker file, I wrote everything that get the Ubuntu from Ubuntu, right? Install this and this on top of it, and ultimately, expose this port, and then it packaged as an image. And when you run that image, please run this particular command. That is Apache 2 CTL, Apache CTL D foreground, so that it runs on the, the Apache 2 service. Are we clear on this, guys?
Yeah.
Yeah, Vishal.
Sunil, what about you? You were there, Sunil, in the meeting?
Oh, yeah. I joined a little late.
Okay, you joined a little late. Fine. Junaid has joined. Okay, I don't think so. Fine, cool. So we are all clear, right, on this point. Bhagavan, clear?
Yeah, yes. Okay.
Okay, fine. All right, let me see the participant list once. Oh, Junaid is here. Okay. I think Moina is not here.
Minus left.
Moina left. Okay. Fine. All right.
And this guy,
Huh?
Ankit also left.
Ankit came. Oh, guys are coming and going. Anyway,
Before that, Sunil, there are 11 members.
there are 11 members, or two of them is me only.
Probably there will be supposed to be 12 members.
Okay.
Sunil. And now there are only 9.
That means either people are not understanding or they're understanding too much. Moina was there. She just left, I think. Anyway, fine. So far everything is cool, right? It is understandable, right? Yes, Malika. What about you? I'm asking everybody in the meeting. I'm not asking you only. Huh?
Yeah,
Clear.
yeah, we have to practice. And also regarding the Docker networking, it's like difficult, I think, right?
Docker networking, first understand Docker Swarm first, then you will understand Docker networking. When you do Docker Swarm, you do Docker networking will be very clear. Docker Swarm, of course, not today.
Okay.
Right. So we have done a lot of things now. There is one thing left, which is known as Docker Compose, right? Docker Compose does not directly get downloaded to the Docker package. I mean, Docker Compose you have to install separately. So Docker Compose we shall not do today because you will not understand it today. So first of all, work with this one. So Docker Compose is kind of when you're trying to, Docker Compose is like a main switch. So what do you do? Let's say you're going to your ODC, right? In your ODC, a lot of lights are there and a lot of ACs are there and all those things. Nobody switches them on and off separately, right? All the switched on. You just, when the last person gets out or the admin team, they will switch off the main switch. when again the next day morning the switch is on the main switch, so all the lights and everything will be. That is the idea of Docker Compose. So in the Docker Compose, what do we do? We do not really go for like what should I say? Let's say you have got a lot of Docker files, right? You have got multiple deployments, so you have got them right, written over there. So all these Docker files you want to build together and run them, right? Or stop them together. So when you're doing this, it is much more easier to do with Docker Compose. Some might be Docker files, some might be directly you're pulling from Docker Hub, right? No manipulation, whatever you're doing. So that is much more easier to do using Docker Compose. So Docker Compose we shall do tomorrow. You should learn about it. So we'll quickly do tomorrow Docker Compose, and we'll do the CD, continuous deployment part, right? Continuous deployment on a Docker machine. So we'll be having our Jenkins. We'll be setting up our Jenkins machine. Also, I shall talk about Selenium a little bit. Selenium, you do not need to know like end to end of it, but you just need to know what it looks like and how it is. So that's very important. So we'll talk about it, and then ultimately what will happen? We'll be like once we build a job, we want to get it deployed automatically once a build is done, because you have already seen that how the build can be automated, right? Using the polling frequency of 5 stars. You remember poll SCM, that
Yeah, yeah.
whenever there is a change happening on GitHub, it automatically polls the SCM and it does a build, right? And also you saw how to add a downstream job to that. So one job is the building job. Below that, let's say there is another job, testing job, and whatever you want to do. So you connect all the jobs together. When ultimately the entire process is successful, you want it to be handed over to a Docker machine, right? And then ultimately creating the environment and the deployment on top of it. So that is how we want this particular thing to work out. So I mean, the ultimate effect should be that we change something in GitHub, and that gets deployed. So the entire thing will be automated. The changing, and after that coming to Jenkins, after that going to the Dockers, creating the environment and deployment. So the from outside, if you see you change one line in GitHub, you say you commit that change, and you see that your deployment is being done. That is the CI/CD together, right? So that we shall see tomorrow. So tomorrow's class will be a little bit more intense. So last week Friday, I forgot to upload the video, so I did it yesterday. Sorry about that. So today I'll upload the video right after this. I mean, right within 5-10 minutes or whatever time it takes to render the video. I'll upload it right now. So I'll suggest you people to actually be very good in this particular thing. Otherwise, tomorrow you'll be having a little tough time to understand what is going on, because from Jenkins we'll be issuing these commands. We'll not even touch the Docker machine. We'll install Docker in a machine. We'll just leave it. From Jenkins, we'll be issuing all the commands, all the Docker build command and everything, Docker stop, Docker RMI, Docker RM, whatever is there, that will be done from Jenkins machine, not from Docker machine. So it will be triggered from there. So that thing, in order for you to understand, you need to first understand this Docker thing first. So take a little time, give a little time to yourself and understand this. Otherwise, tomorrow it is going to be a little tough. Fine. So I'm not trying to demotivate you, but I'm just trying to say that go through this one. Otherwise, it will be very difficult. And CI/CD pipeline you have to understand in a very good way. Otherwise, it will be very difficult for you to go for that. Right? I mean the tools you can know, but if you do not know the integration of the tools, that will become not very fruitful thing. Right? So that's it for today. Go ahead and practice it out, and let's meet tomorrow. Stop it over here. Any last question from anybody? Yes? No?
Nothing.
Okay. Bye. Bye-bye.